Hi students, in this video I'll be going through the 2023 A Math paper 1 question 6. Right, so this is a question relating to differentiation as well as the increasing and decreasing functions. Okay, so let's start by reading the question. The function f is given by fx equals to ax squared over x minus a, where x is greater than a and a is a positive constant. So find in part A, find f prime x. So basically find the first derivative for fx. Okay, so let's start by the question. So fx is given as ax squared over x minus a. So now we want to differentiate fx. Okay, so for this algebraic fraction, we will need to apply the quotient rule. So over here we have the numerator, and over here we have the denominator. Okay, so if you recall, how do we apply the quotient rule? We will differentiate the numerator first, so you'll get 2ax. Okay, then we won't touch the denominator, so we'll multiply it by the product of the denominator. Then we will subtract. Okay, so for the second part over here, we will differentiate the denominator instead. So if we differentiate x minus a, will just be left with 1. Okay, then now we will multiply to the numerator. Okay, then for denominator of the first derivative f prime x, it will just be the denominator of the original function squared. Okay, so let's just try to simplify f prime x now. Let's expand the top. We'll get 2ax squared minus 2a squared x minus ax squared over x minus a squared. Okay, so you notice that you can actually group these two terms together. 2ax squared minus ax squared, you end up with ax squared minus 2a squared x. So they are different. Okay, so be careful. Over x minus a squared. Okay, so at this point in time, of course, you can factorize out a and x from the numerator, but that wouldn't really help to simplify the expression by much now. Okay, so we can just leave our answer as this. Okay, for part A. Okay, let's take a look at part B. Right, so part B states that the function g is defined for x greater than a also. It has the property that g prime x equals to x minus a squared times f prime x. Okay, so this will actually allow us to find the expression for g prime x. All right, so let's just find that first. Okay, so a lot of times it's just about following instructions. Okay, so times f prime x over here. By f prime x, we have already found it in part A already. So we can just take this one and then replace it, okay, in the expression for g prime x. Okay, so that's basically what we are going to do. So we'll multiply by ax squared minus 2a squared x over x minus a squared. And from here, you can see that actually we can cancel off these two terms. So that's actually the purpose of having this one over here when they design the fraction. So over here we will have ax squared minus 2a squared x, okay, for the expression of g prime x. Okay, so the next part of the question, they give you some more further info. G decreases for x greater than a and less than 8. Okay, so basically now what they are saying is that this function, okay, or this graph, which should be a curve, right, is decreasing, okay, for this range of x values. Okay, so what can we say about a decreasing function? Okay, what can we say about the gradient of a decreasing function? So basically for a decreasing function at any point okay, of the graph, right, the gradient will be negative, okay? And basically the gradient function is this, okay, this is the gradient function g prime x. So now basically what we need to do is we need to set g prime x to be less than 0, okay? And then we try to solve the inequality and see whether we can get something close to this or not. Okay, so if g decreases, okay, then g prime x will be less than 0. Okay, so g prime x expression we got earlier on, so this will be less than 0. So now basically we need to solve this quadratic inequality. Okay, so what we can do is we can factorize out a and x. Okay, then here will be x minus 2a. Okay, so this is what we'll end up with. Okay, so if you recall, how can we solve a quadratic inequality? Okay, we just need to do a rough sketch of the graph. So since A is positive, right? Okay, the question earlier on mentioned that A is positive. Okay, A is a positive constant. Okay, so in other words, when we sketch out this particular function over here, we will get a smiley face. Okay, so what are the two roots? So one of the root will be x equals to 0, right? Okay, basically you just put this one 0 and you find the two x value. One will be 0, the other one will be 2a. Okay, so since a is positive, then 2a should be on the right side of 0. Okay, so now we want region less than 0, so we want this part, okay, of the graph. Okay, this part. Okay, so what we end up with would be x greater than 0 and less than 2a, right? Okay, but then there's a clue over here that they give us. They say that it decreases for a range of x greater than a less than 8. Okay, but if you look at this, so what they want is x greater than 0, a and less than 8, right? Okay. Okay, but our left side over here is x greater than 0. So how do we try to get something very similar to this? Okay, so that's basically okay, you need to pay attention to the question. Okay, over here they told us that x is greater than a. Okay, so we need to combine these two conditions together. So one condition that we got by solving this quadratic inequality is x greater than 0 less than 2a. Okay, but okay, at the same time, x given in the question is greater than a. Okay, so we need to combine these two together to get the overall result. Okay, so let's use a number line to illustrate this. Okay, so now we have 0 here and 2a. So from the first inequality over here, okay, which we got by solving the inequality on top, okay, x is greater than 0 but less than 2a. So this will be the range of x. Okay, then the condition given in the question, okay, the second inequality, x is greater than a. So x is greater than a. Okay, so remember when you want to combine two inequalities, you will take the overlapping region. Okay, if you look at this shaded region that I just shaded, what we'll get is x is greater than a but less than 2a. Now we have something very similar already, and then we can compare, okay, the two inequalities to find the value of a. All right. So if by comparing, you see the left side is already the same. Okay, so this means that 2a has got to be equals to 8. All right. So by comparison, okay, 2a will be equals to 8, and then a will be equals to 4. And this is basically what they want us to find, right? Okay, they want us to find the value of a, right? Okay, so this is not a very typical question, but at the same time, if you know your concepts well, then it's actually not a typical question as well, right? So I hope this explanation is clear for you.